Hi everyone, let's learn casting lemma in this video. So here you can see the statement, okay, and this is my notes. To make learning easy, I made this notes. Okay, so this is the statement as it is named lemma. In the examination, they may ask you state and prove casting lemma. Okay, so we have to know the statement also. Okay, let's start with the statement. Let x equal to A union B. Here A and B are closed in X. That is the first sentence you have to write in the statement. X is a topological space, okay? And you are defining like this: X equal to A union B. In the set X, there are two sets that are A and B, okay? When you find the union of these two sets A and B, you will get the topological space X. That is what you come to know from this. Okay, X equal to A union B. Here A and B are closed in X. Okay. Let also F from A to Y. So you are defining two functions here that are F and G. So this function F is from the set A to Y, and another function that is G, that is from B to Y. Is that clear? Okay. These two functions are continuous. When these two functions are continuous, if f of x equal to g of x. Here you have this x, right? This x belongs to A intersection B. So if these conditions are there, then f and g will combine and gives a function this h from x to y. This is defined by h of x equal to f of x if x belongs to A, and h of x equal to g of x if x belongs to B. Okay, this is what the statement. Now here you are going to start learning the proof of this theorem. Okay, proof of this lemma. So here first you are writing, you have to write the given. Given means what? Given x equal to A union B, where A and B are closed in X, and f from A to Y and g from B to Y are continuous. Also f of x equal to g of x for all x belongs to A intersection B. Everything you have wrote from the statement. Am I right? Okay. Now define. This is also you are writing from the statement. Okay, h of x equal to f of x if x belongs to A, and g of x equal h of x equal to g of x if x belongs to B. All these you have wrote from the statement. Now we have to prove this h from x to y is continuous. That is what our intention. Okay, so here we know that if you want to say a function is continuous, okay, what we will do, you will take in the previous theorems what you have done, you took an open set from here and you will say inverse of this open set is open in here. If you say that, then you say that function is continuous. That is what the general idea. Here what you are doing is, here you are taking closed set from this y, that is C, and you will say inverse of this closed set is closed in X. Okay, that is what at the end of this proof you will do. So here you are taking closed set, right? So that is why here you are putting union, and in the I'm comparing this with another theorem. Okay, in another theorem, that is I explained to you earlier, you can see that in my playlist topology. Okay, there is a videos under topology in my playlist. You can go and refer if you need. Okay, so here you have an theorem maps into products. So in this theorem also you will say in the converse part f is continuous. You will prove f is continuous. So the same ideology you will use, but here in here you will put intersection, and in our pasting lemma you are putting union. I will tell you the reason for why you are putting here intersection and why you are putting union in pasting lemma. The reason is because here you are taking open set, here you are taking closed set. That is what the reason, okay. The concept is same in both the proofs. So here you are taking a closed set from this y, and you are going to say inverse of this closed set. That is, the closed set here is C. Inverse of this closed set is F inverse of C, that is closed in X. That is what you are going to say at the end of this proof. So in between, to say that you have to prove this. If you prove this, then obviously this condition will be proved. Sorry, what condition will be proved? This condition, H inverse of C is closed in X condition will be proved, and if this is proved, then this will be proved. Okay. I think you are not getting confused by my notes. I hope. Okay. In the first line, first you have to write everything given in the statement. Then in the next line, what you have to, I will tell you, okay, to avoid confusions, I will tell you what you have to do in the in each steps. In the next line, what you have to write is to prove H from X to Y is continuous. So to say if H from X to Y is continuous, what you have to prove? To prove H inverse of C is closed in X. That is what you have to prove. So to say that, before that, I'm so sorry, before that, after writing this line, you can write, let C be the closed set in Y. Then after this, you write that is to prove, okay. After this line, you write that is to prove H inverse of C is closed in capital X. In the next line, again you write that is to prove H inverse of C equal to F inverse of C union G inverse of C. Okay, you are going to prove this now. You are taking one element from here, and at the end you will say the same element is in here also. That is what you are going to do. X belongs to H inverse of C. So if and only if you are bringing this H to this side, so you get H of X belongs to C. If and only if we define H of X equal to two things, right? You are going to use this here. F of X belongs to C, Fx belongs to A, or G of X belongs to C if X belongs to B. Now if and only if you are bringing this F to this side, so that you will get this. And in between you have R, so that you are putting if and only if X belongs to F inverse of C. Here what is mean by this R? This X is this or this. Okay, it means you can put union. X belongs to F inverse of C union G inverse of C. Now you got this X. At first you took X from here. Now this X is here. Okay, so you can say that this equal to this. That is what in the next line you are writing. Now, since F is continuous, there the given part you have wrote. Okay, the given you have, since F is continuous, we have F mapping in the statement, F from A to X, right? Since F is continuous, what you can say, from X you are taking closed set. These concepts are there in between these lines. Here in my note you could not see all those lines. Okay, without understanding, if you learn, you will get confused. So that is why I'm telling you, since F is continuous, we have a mapping F from A to X in the statement, right? So from this X, you are taking a closed set, that is C. It means what will happen? In the question itself, they are giving you continuous. It is continuous. It is obvious. So what is mean by this? F inverse of C is, it's a closed set, right? So F inverse of C is closed in A. Okay. That is what this line means. Also we have A is closed in X in the statement. So that you can say F inverse of C is closed in X. Okay. Similarly, you are writing for G. Since G is continuous, G inverse of, Okay, since G is continuous, here G, this is a mapping for G, that is in the statement. So from here you are taking a closed set, that is C. Since G is continuous, you can say F inverse of C is closed in B. That is what this line, G inverse of C is closed in, I wrote it in a short. Okay, B is closed in X, it is in the statement. Therefore you can say G inverse of C is closed in X. Okay. Therefore, you can say F inverse of C, if F inverse of C and F inverse of C and G inverse of C are closed in X. What is mean by this? When even if you take the union of these two, that will be also closed in X. That is what this line. Hence, if this is closed in capital X, then the left hand side also closed in capital X. Okay. Therefore, H is continuous. Finally, we proved it. Okay. I hope I did not made any confusions. Okay. Here you look at this proof that I got from the college. Sometimes you may get confused by seeing my notes, right? So I don't want that to happen. Look at this. Okay. You can make note of it. Copy it. Here I must tell you something. You have to watch this video by keeping that video quality in high. Okay, keep the video quality high. Only then you can see all these letters. Otherwise there will be blur. Okay, thank you.